Well, so earlier we have discussed reflection by the spherical surface, the plane surface, and the different types of reflection, the laws of reflection, the total internal reflection, etc. And now we are proceeding with refraction. In refraction, basically, we have to consider two media, like one is a rarer medium and other is a denser medium. Normally, it is found that whenever a ray of light moves from a rarer to the denser medium, then the ray which is moving in the rarer medium is called incident ray, and the ray which is moving in the denser medium is called the refracted ray. It is found that when the ray of light moves from rarer to the denser medium, it always bends towards the normal. So, angle of incidence is always greater than angle of refraction. But in a reverse pattern, if the ray of light moves from denser to rarer medium, we find that the ray of light, when emerge out in the air, it moves away from the normal. So, when ray of light moves from denser to rarer medium, angle of incidence is smaller as compared to angle of refraction. These facts we have to go through with, and then we have to just go through with the successive refractions at the glass slab. And what is real depth and apparent depth. So these facts we will discuss in the portion of refraction. So we first of all come towards the main concepts regarding the refraction of light. The bending of light ray from its path in passing from one medium to another medium is called refraction of light. So when we say one medium to another medium, obviously it is from rarer medium to the denser medium or from denser to rarer medium. When a light is moving from one medium to another medium, it always either bends towards the normal or it moves away from the normal. From rarer to denser medium, we find that ray of light will bend towards the normal. In that case, angle of incidence will be greater than angle of refraction. Similarly, when light is moving from denser to rarer medium, we find that angle of incidence will be more than angle of refraction. So, now we come to another concept. If refracted ray bends towards the normal relative to incident ray, then the second medium is supposed to be denser than the first medium. But if the refracted ray bends away from the normal, then second medium is said to be rarer than the first medium. This is what I have suggested earlier. In the context I have spoken, that is, the rays of light always bend either away from normal or towards the normal. So rarer to denser means bending towards the normal, and from denser to rarer, the bending is away from the normal. Now the two figures are shown here. That is, in the left figure, the upper portion is rarer and the lower portion is denser. Normally we take it as air and water. We can take it air and glass also. So incident ray is shown, the script is written, incident ray. The normal is indicated by the dotted line, and refracted ray is indicated in denser medium. And as I have spoken earlier, I is greater than R. So R is within the denser medium and I is in the rarer medium. And now we see the second figure, that is towards the right. We are finding that the wave is moving from denser to rarer. So refracted ray bends away from the normal, and angle of incidence will be smaller as compared to angle of refraction. Now we come towards the laws of refraction. They are very similar to the laws of reflection, but there is slight difference, that is about the bending. However, we know that incident ray, the refracted ray, and the normal all meet at a point in the plane. So, for any two media, for light of a given wavelength, the ratio of the sine of angle of incidence to the sine of angle of refraction is constant. That is, refractive index is sine I over sine R, where I is angle of incidence and R is angle of refraction, and it depends upon whether the light is moving from rare to denser or from denser to rare. So, for two media, the light of given wavelength, like for example, we consider the light as red, the wavelength must be taken as about 7,000 angstrom units, and then we have to take the ratio of sine of incidence angle and the refraction angle. So that ratio is found to be constant for that particular wavelength. If the wavelength will change, then the value of mu will begin to change. Sine I over sine R is constant, and I is the incidence angle and R is the refraction angle, and this constant is called the refractive index. The incident ray, the refracted ray, and the normal at incident point all lie in the same plane, as I have spoken earlier. The refractive index of second medium with respect to first medium, that is designated by N12, that is N12. We can write also mu12, that is the refractive index of second medium with respect to first medium. It is equal to the ratio of N2 and N1, where N2 is the refractive index of the second medium and N1 is the refractive index of the first medium. So refractive index of the medium, that is N or mu, that is all the same thing. So we find that velocity of light in vacuum divided by velocity of light in medium, that is C over V, that is sine I over sine R, and that is equal to N. N means refractive index. So refractive index is given by sine I over sine R, or we can say velocity of light in vacuum divided by velocity of light in medium. So in medium we represented by V, and in vacuum we represented by C. Always remembering that light is electromagnetic wave and it can propagate with or without the medium. So medium is not one of the essential property for the propagation of light. Moreover, the velocity of light in vacuum or in air is generally calculated with the help of Maxwell equation, which is V1 over square root of epsilon naught into mu naught. If we put these values of epsilon naught and mu naught, epsilon means absolute permittivity, mu naught means absolute permeability. For air medium, we put two values to get the velocity of light in vacuum or air, which is found to be 3 into 10 to the power 8 meters per second. Refractive index is a relative property of the two media. If the first medium carrying the incident ray is vacuum, then the ratio sine I over sine R is called the absolute refractive index of the second medium. So sine over sine R will represent the refractive index of the second medium. More elaborately, it should be absolute refractive index. The relative refractive index of any two media is equal to the ratio of their absolute refractive indices. Therefore, if the absolute refractive indices of the media 1 and 2 are N1 and N2, or we can say mu1 and mu2 respectively, then the refractive index of medium 2 with respect to medium 1 is. So we write 1 and 2 means refractive index of second medium with respect to first, that is equal to N12. So it is written as N2 over N1, that is sine I over sine R. Now N1 sine I equal to N2 sine R, where I and R are the angle of incidences and the angle of refractions. So N12 is equal to 1 over N21 because it is a reciprocal number. For three mediums, if we have got 1, 2, 3, due to successive refraction, we can write an equation that is N12, that is the refractive index of second medium with respect to first, multiplied by refractive index of third medium with respect to second, multiplied by refractive index of 1 with respect to 3, their product is taken as 1. So we can write them as N2 over N1, N3 over N2 multiplied by N1 over N3, and all of them will be equal to 1. So N2 will cancel off, N1 will cancel off, N3 will cancel off. So N12 can be written as N2 by N1. Similarly, N23 can be written as N3 by N2, and similarly N31 can be written as N1 over N3. Now, refractive index of water with respect to air, that is written as NW over NA. If it is multiplied by refractive index of glass and divided by refractive index of water multiplied by refractive index of air divided by refractive index of glass. So according to the previous equation, their product will be taken as 1. So the first part is written NW over NA. So it is basically a refractive index of air with respect to water. Second can be taken as refractive index of water with respect to glass. And third fraction can be taken as refractive index of glass with respect to air. So NAW multiplied NWG multiplied NGA equals to 1. And this is indicated in the adjoining figure. That is, the incident ray of light is passing from air to water. So it is bending towards the normal, then from water to glass. That is from rarer to denser again. It is bending towards the glass. That is the normal. Then emergent ray is moving again in air medium. So obviously it is shown that it is bending away from the normal. For two mediums with refractive indexes N1 and N2, which can also be written as mu1 and mu2, are the refractive indices with respect to vacuum. The incident and the emergent rays are parallel. Then in that case, N1 sine N1 will be equal to N2 sine N2. We can remember that N1 and N2 are the refractive indexes of the two media. Now we are seeing in the adjoining figure, there are there are first medium, then it is the second medium, and then the third medium. In the first medium, the ray of light is coming from rarer to denser, because we find that in the second medium, the ray of light is bending towards the normal. Now it is moving from denser to rarer medium, and we are finding that after emergence, it is moving away from the normal.